All right, welcome to the Upstream Science Podcast, where we dive deep into the forces shaping human health from the inside out. My name is Darren Beckett, and today I'm joined by Dr. Amine Zorgani, a brilliant microbiome scientist whose work explores the incredible world of the trillions of microbes that live inside us and their functions in human health. Together, we're going to dive deep into the secrets of the gut microbiome, why so many people are struggling with gut dysfunction, and how the microbes that live in tandem with us shape everything from digestion to mood and immunity, and what it really means when we talk about good and bad bacteria. We'll also be exploring the fascinating role of human-native microbes like Bifidobacterium adolescentis that support our health in dramatic ways, especially when it comes to something as common as, say, lactose sensitivity and digestion challenges. We'll also be exploring how precision prebiotics set the right nutrient foundation for beneficial microbes to thrive. All right, super excited to chat. Let's jump in. Welcome, Dr. Zorgani, to the Upstream Science Podcast. It's a pleasure to be here with you.
Likewise, thank you so much, Darren, for the invite. I'm pleased as well to contribute with very humbled about the knowledge I have. I think we haven't learned that much on the microbiome, and we will probably still have a lot to learn every day. I think that, okay, we've actually discovered it all, but every day I think, no, we haven't. So very, very much excited to be with you here.
Yeah, it's super exciting, and because of the vastness of the gut microbiome, would you mind, just starting off with sharing a quick 411 on what the gut microbiome is, maybe for listeners who are unfamiliar or are learning? And it's probably a question that you get quite a bit, and one that we repeat quite often. And so I would just love to hear your unique stance on this.
Honestly, funny enough, I think I would take the answer of a person or a lay person actually was asking in an interview on we call it in French, radio trottoir. It's basically is the question when you ask a person outside, and then there was this guy trying to interview people, asking them about if they know what the gut microbiome is. And this guy naively said, isn't it the zoo of microbes? And I think he actually nailed it. It's a zoo of microbes, because in the gut microbiome, which is basically most of it in the small intestine, right? You have a zoo of microbes, several types of bacteria, fungi, viruses. Not all of them are bad, because that's the connotation we get when we speak about bacteria or pathogens or viruses. We think of COVID. Now, when we speak about a virus, the first thing that comes to people's mind is COVID. While in the case of the microbiome, we speak about viruses of bacteria, also known as phages, which are, they work like a sponge. They modulate the composition and the quantity of the other bacteria in the gut microbiome. We also say that almost probably 98% of the bacteria that is inhabitant of the gut is beneficial, right? So we do have some pathogens that, stick there for the sake of bothering the others, but not to harm, the individual, but they still there just to keep the balance. And, usually if there is only happy people, is not a good place to be. So sometimes you get some annoying people as well. So in essence, the microbiome is the definition of the bacteria, the viruses, and the fungi, and some parasites as well that actually lives within the gut. But the biome, the microbiome, or the microbiota is the organisms themselves. When we say the microbiome is the organisms themselves and what they produce, right? Because a bacteria, let's say if you stick to that, which is mostly when we speak about the microbiome, we speak mostly about the bacteria. They are not there for the sake of being there. They are interacting with themselves, with the other bacteria that are neighboring. In an individual adult, we anticipate to have around 730 different species of bacteria, right? That are living within someone's gut, and they are variable. And again, there is a crisis in that extension of these microbes, because if we compare our microbes as in industrialized civilization to the people living in hunter-gatherers and those tribes that are isolated, they have a much higher number of bacteria living in terms of diverse in their guts. So the bacteria, they interact within each other, within the ecosystem, but also they interact with the immune cells. When you're born, the first thing that you encounter is this bacteria that you get through natural birth, through the vaginal canal from your mother, or from the skin if you are C-section. And this actually triggers the immune system and starts producing some molecules. So so in a short saying, you are a microbial than you are a human, because for each cell of a human, you would have another cell of bacteria. But more importantly, from a gene perspective, you have 150 genes of bacteria accounting for one gene of a human being. So genetically, you're a microbe. Actually, you're not a human being. In your gut, you have more than 1.5 kilograms of bacteria as a mass. So it's just a vast ecosystem functioning in a symbiosis with you in that way.
Wow. So we're aliens, right?
More or less.
Yeah. I want to double click on something you said, which is the difference between good and bad microbes. The reality is obviously, more nuanced than that. I try and think of context, balance, and you said diversity, more than the labels of good and bad. In a lot of gut microbiome stool testing, diagnostics, they're often looking for the bad. So how would you think about that distinction between, what we should have in our gut microbiome and what we shouldn't?
It's a great question. And it is 100% context dependent, right? So let me give you the simplistic way of looking at it. Let's just take a healthy human being that is just born, right? So your microbiome, when you are a fetus, you are technically sterile. At least the latest research showed, we had the controversy that, some fetus would have some microbial signature in the womb before they are born, but eventually we got a very large study published this year showing that a fetus is sterile, so you wouldn't have any microbes in the womb.
So no microbes in a fetus?
No.
Wow.
That's the final agreement until there is some other researchers saying the other way.
Fair enough.
But we agreed that, okay, a fetus is sterile. When you're born only two ways, either through the vaginal canal or through a C-section. There is no other way. So if you are born vaginally, the first colonization you get is from the vagina. And that's mostly lactobacilli and some E. coli that goes with it, some bifidobacteria that also comes with it as well. If you are born from a C-section, the first microbes you get is skin microbes. They're coming from the mother, but most importantly from the midwife's skin, because that's what you get as well. Interestingly, some hospitals in China, they made it as a routine, method to do what we call it vaginal microbiome transplantation. It's not what you think of, taking a vaginal microbiome from one woman to another, which is another practice. They basically, before the baby is born, they take some gas and cotton to swab the woman's vagina when she get the first discharge before the birth, and the moment they are born, they cover that baby, if they are C-section born, with all that bacteria to enable them to get the same benefit if they were born vaginally, right? Here you would think that if a baby is born vaginally, they would get a very high diversity and so on and so forth. Interestingly, when you're born, you have an extremely, extremely low diversity, because that's what's needed for your body to function. You cannot get the same microbe as if you are an adult, because that will be insane from your immune system.
Yeah, it'd be overwhelming.
Exactly, it will be very much overwhelming. So you get very little of colonization. And interestingly, E. coli, Escherichia coli, which is also known as some of the pathogens, is one of the first colonizers. Like the first bacteria that you get in is E. coli, and then you get the other very good bacteria, like you've mentioned, Bifidobacterium emphantis, Bifidobacterium adulensis, and Bifidum, and Longum, and the rest. When you start lactating through the breastfeeding, you start getting the lactobacilli, right? And you get less of the E. coli, they start disappearing. So basically, there is a symbiosis that actually happens there, and there is a competition between some of the bacteria with the others. Some clear the space for others, they take space, they get more diversity. When you start eating some food, you get more bacteria. And then when you start getting to the adolescence stage, this is a more of the black box. Most of the research is done from 0 to 1,000 days. We call it the 1,000 days for a reason, because they are very much influencing your cognition, your, susceptibility to allergies, to infections, and so on and so forth. That's early stage of life, extremely, extremely important. But what's funny, the research ignored more or less the ages between 6 to 18 years old. Go and look into the research. You find really small amount of clinical studies looking at adolescents. Funny enough.
Sure.
Right? So we don't know that much about them. What we know that the microbiota stabilizes at around the age of 5, start getting similar to the adult one around the age of 16, 18 years old. And then it stabilizes from the 18 years old all the way up to 65 years old, when you start declining again and losing diversity. So you start very low diversity as you're born. You start getting diversity when you get to the adult stage. And when you get to the elderly, you start losing. It's like you're losing some of the functions that you already acquired in some sense. Here, we're only speaking about a healthy one. So if we say a high diversity is good, we're wrong, because a high diversity of a baby is really bad. If they have a high diversity, they are not in the right path. If we speak about the elderly, a low diversity in some cases is good, because that's their body is, adapting to some of those changes, unless they have other differences in the immune system and how they react. So this is in the context of a healthy. When we speak about a disease, we usually abstract towards the adults, simply because we do less research into the elderly and less research into the infant. So when we speak about an adult in a dysbiosis, which is an imbalance of the microbiota, then we'll start looking, okay, are they having much in terms of quantity of bad bacteria compared to a good bacteria by the definition of what is good or what's bad? But we're looking more of a bacteria that the science has identified as pathogenic or opportunistic pathogen. So it's not pathogenic usually. Let's give you an example. Fusobacterium nucleatum, it's an oral bacteria, right? When you're an oral cavity, it technically doesn't do much, besides probably some ulcers if it develops farther to cancer in very rare cases. But it's usually is not harmless. It's harmless. But if it gets into the colon, Fusobacterium nucleatum at certain levels or quantities is considered as the third cause of colorectal cancer. So if you are having a microbiome test and you found the very high quantities above what a healthy cohort or a healthy population would have, you would consider that as a factor of risk that you need to probably further investigate with an oncologist in that sense. We have yet to reach a diagnostic level in some many cases, but interestingly, we did manage to get diagnostic value of microbiome testing in IBD, in IBS, in many other diseases, where today we say if there is this typical microbiome signatures, meaning specific microbes that are present or absent, we could infer or diagnose certain types of diseases in a specific context.
Yeah, wow. So much to digest there, no pun intended.
Yeah.
You know, as you already said, right, you were describing this process of a healthy human. Like if it were a perfect world, there'd probably be a low diversity at birth, a higher diversity throughout the life, and then at the end,
A lesser.
less diversity at the end. And then you're also describing, right, there are different microbes that are beneficial in certain locations in the body, in the digestive tract, and what you just said, right? There are some healthy microbes like for the mouth that would actually play a different role, maybe in a non-beneficial way, maybe lower down the chain, so to speak.
Yeah.
And what comes to mind is, why are people suffering so much? Why is bacteria, like SIBO, right? Why is there bacteria where it shouldn't be? And what are the things that you're looking for and thinking about when you're thinking, why is the world like this? Why is it that we have this natural ecology system that is supposed to flourish and support our health? We didn't even know it existed until fairly recently. And then we didn't know that it was a healthy thing for us. As you said, a lot of people see bacteria as bad. What are your thoughts on, I'm sure we could go down a rabbit hole, but what are some initial thoughts on this kind of slipping mechanism, right? What are the things that are happening to people that are allowing these microbes to not be in their quote unquote place?
No, it's a great question, right? So I give you a very clear and easy example how human behavior can actually impact the microbial composition, and down the line impact the physiology, and down the line create diseases. And this is a fairly new type of, let's say, condition. It's probably not a disease, but it's a condition. Let's call it like that. When COVID hit, we started using masks, right? So it was a mandatory thing to use masks. Within that, there was a new condition called maskne. Have you heard of it?
I have not.
Maskne, it's an acne that is only induced when people wear masks for a long time.
Okay, makes sense. You're breathing into the mask. It's kind of like staying on the skin.
You breathe into the mask and you get that. Acne is driven by a bacterium called Cutibacterium acnes, which is a skin commensal, right? So it's a skin bacteria that your face is composed by around 95% of the, again, we don't have microbes only in our guts. We have microbes in our skin, in our mouth, in our ears, even in our eyes, and again, in the surroundings. So when the human behavior change and enforce the mask use for a prolonged period of time, it created a humid environment that enabled some of the Cutibacterium acnes strains, to overpopulate the skin and create the acne. And obviously, afterwards, if you remove the mask and you put the treatment, the acne may or may not disappear, depending on whether or not you would influence the bacteria to go back to the level they were, right? So the human behavior changed the microenvironment of those bacteria on your skin, gave them the conditions to flourish, to induce the acne. It's the same process that goes along within the gut microbiome. If you create a condition where certain types of microbes that are at a very low levels, they exist, but they're at very low levels, they're harmless in the sense of their quantities are outcompeted by the other beneficial bacteria, right?
Mm-hmm.
If you provide a condition where it's high fat, high sugar, some of those microbes, they have the tools, they have what we call them the enzymes, to be more competitive and digest more of those sugary McDonald's and, the the things that some of the Gen Z likes as well.
So easily available to us these days.
So easily available, so cheap, and so on and so forth. The processed food is on the bench, and you take it and you don't even know what it is. Most of it is food preservation that is designed to kill bacteria, right? That's what the food preservation means. Preserving the food is putting ingredients to kill the bacteria, to enable them, obviously to make your food safer, but eventually you're actually killing some of the bacteria that, again, consuming, I don't know, I don't want to put names, but consuming, let's say, a snack that has food preservation probably once a week, it won't kill of your bacteria, maybe probably 0.001%. But putting that on a daily basis, morning and evening, it will be a different story. Again, we'll not get into the processed food thing, but what I'm trying to say here is that our behavior had changed and into a complex way. So we've increased the consumption of food with processed food and packaged food, filled with the preservation, full of sugar, full of fats. We increased our hygiene. That's what we call the hygiene hypothesis. We now using cleansing almost every time. We go very much less into the nature to get embraced with the forest and, the microbes that we get from there. And more importantly, we've been more sedentary. We're in the houses, we're in the four walls and stuff like that. So it's it's a complex mechanism, mostly from the exposome. The exposome is everything that the human body is exposed to, which by all means reduces our microbial diversity. Since we have been able to correlate 99% of diseases in one way or another correlates with a microbiome or the gut microbiome. 99%.
Wow.
So, in a context of an adult and a healthy adult, touching that microbial diversity of the gut is touching the balance and their health status, right?
Yep.
Again, if you destroy that balance, you're by all means enforcing creating a dysbiosis that anyway would lead to a gut-brain axis. We're talking about mental health, neurodegenerative diseases, Alzheimer's, dementia, Parkinson's disease. We're talking about the gut-liver axis, NASH, fatty liver disease. We're talking about gut-bone axis, the gut-eye axis, the gut-lung axis with all the COPD diseases and so on and so forth. So that's the balance we have. If we put the exposome in a different, non-natural way, we destroy the balance.
Wow. When we think about the food we eat and whether or not it is good or bad for us, I think, and I just want to get your take on this,
Mm-hmm.
and I'm just exploring it for myself here in this moment. We often think, is a food toxic for us or not? Is it going to make us sick? Is it going to bring a lower value of health? And although that may be true, maybe there's another layer here that you're revealing, which is that the food may not be toxic for us, but it is toxic for the bacteria that thrive with us. Yeah. And I think that that's maybe something that is hard to understand scientifically if you don't know about the gut microbiome, because, certain things like pesticides or gene editing for certain, foods, certainly corn is used in so many different ways, especially here in America. And we might think, logically, okay, that process is actually toxic for us. And what I'm hearing is maybe it's not toxic for us, but it's toxic for the things that help us thrive. Would I be accurate in that statement?
You are very accurate. And I think it's more of the ignorance of the value of the microbiome that actually induces that, that process, right? Just give you a very, very easy example to comprehend. You have a car, right?
Sure.
Yeah. Before you put the diesel or in your car, or maybe the oil, just to make it more complex. There are different types of oils, and we have these references in them. Would you just go and just get any type of oil and throw it into your car, and you think, okay, that will work?
I did that. I put 16-wheeler oil in my truck when I was in college, and it was a disaster.
Exactly. But theoretically, you would say, okay, maybe I should not put any type of oil. Afterwards, you would get educated about it, and you would say, okay, for my car, this is the type of oil. Or at least for the diesel or the gas, you would, it's not a petrol, you would put the other way around, or gas, right? So you would, because if it's a petrol car and you put gas, it wouldn't work. I mean, it wouldn't function, right? Because again, that petrol needs to be utilized by the engine, which is a petrol engine, to be able to create energy for your car to actually work. The problem we have now is that our petrol engine is our gut filled with these microbial living organisms, that they are the ones transforming the food we consume, right? So if we eventually put the wrong type of petrol, they wouldn't stop functioning. They actually do function, but in a direction that you wouldn't want to happen. Simply to your car, it will do the same thing.
Yeah, you get a mile and you're done.
Exactly. But this is a big issue, because this is not just about the food. It's also about everything we actually consume that ends up into the gut. If give you an example, some people might think, okay, actually I took this medication, it didn't work, but for my brother or my sister or my mother, it did work. Why? Why do some people respond to some medication and some others don't respond to medication? Yes, guess what? The microbes are transforming some of those drugs into an active or an inactive form. In some patients, they would work, and the others, they wouldn't work. Now, some of the research is doing is that we're actually identifying what microbes are involved into the transformation of that medication, getting the gut ready before you even take the medication, so that you can benefit from it, as well as your neighbor who would have the microbes that you don't have. So if you give you those microbes, you increase your response to those medications. Same for the type of food. You might think, okay, I actually have a lactose intolerance, right? Why? We have also found that there are some microbes, they do actually convert lactose into lactate, and so on and so forth. That some people actually do lack, and we'll get to that later. So it's all about this engine that we have inside, that people are ignorant of its existence or ignorant of its value, because they just don't see it. It's a microscopic thing that I don't even see unless I have a microscope.
Yeah. So let's define a couple of things, right? Because you go to the store, you say, hey, my gut health, I need, whether the person is experiencing gut challenges or, they saw, something that piqued their interest, a documentary, a series, an interview like this, right? And so that you go to the store and you generally see two things, but I think there's a third that's we're starting to see more often. And so I'd like, let's just go through them, right? Prebiotic, probiotic, and a postbiotic. So, people are just like often very confused by these things. Can you lay them out one by one for me?
In simple terms, a probiotic is a bacteria, by the definition of the International Probiotics Prebiotic Association, is a bacteria that it's in the context of health is beneficial to the host being us. So, I mean, if you take a live, very, very important, it's alive microorganisms when taken in an appropriate quantities. Sorry for the noise outside.
Oh, good.
A live microorganism, when taken into an appropriate quantities, confer a health benefit to the host. That's the full definition, right? So, meaning that when you look into a package and it's written on it probiotic, so you would anticipate that is a live bacteria. So it's mostly bacteria. You would also find yeasts like Saccharomyces boulardii, often prescribed in a diarrhea. Very, very effective, actually, some strains of it. But so these probiotics, they usually come into as a CFU or colony forming unit. It's mostly the quantities of those bacteria. It's not always the higher the better, but it depends on the strain and which context they've been tested. And these, when taken, it will give us a health benefit. Meaning, let's say if I take a probiotic to reduce my diarrhea, it needs to reduce the symptoms of diarrhea to be named as a probiotic. If it does nothing in my body, it's usually just a bacteria that I just swallowed, and that's it, right?
Sure.
Now, a prebiotic, it's it's a substrate that, when given to a live bacteria in an appropriate quantities, that live bacteria confer a health benefit. So it's mostly the food of the bacteria. It's not, by all means, it's not the food of the probiotic. So you have the probiotic, which is the live bacteria. The prebiotic is the food of the bacteria, not the food of probiotics, because most people think it's the food of probiotics. Prebiotics, they come in a soluble fiber. They could also come in terms of vitamins, because there are some bacteria that consume vitamins, or any other substances that, if given to a bacteria, the bacteria confers a health benefit. Now, if we give a substrate, let's say a fiber, a soluble fiber that it gets from a cornstarch or fruits or vegetables to a bacteria that lives in our gut, that bacteria produces molecules that are beneficial to our health, we call those molecules postbiotics.
Got it.
Right? So the bacteria, it's a probiotic. The molecules that bacteria eats is a prebiotic. The molecules that the bacteria produces after they eat something beneficial, we call them postbiotics.
Amazing. So just to double click on that really quickly, probiotics are not necessarily the microbes, but we kind of clump them together. And then prebiotics are what feed those microbes. And then postbiotics are the molecules that have beneficial or non-beneficial benefit to the overall health.
Postbiotic is mostly considered as a beneficial. Now we actually, with the new definition, we would consider even as a dead bacteria as a postbiotic, because when you take a bacteria and you heat it, you kill it, it releases some other molecules like the wall of the bacteria and so on and so forth. It's also considered as a beneficial in some instances.
Wow, amazing. So let's dig a little deeper into the concept of like when a company is creating a new probiotic or a new type of pre-pro post, often we hear things like, okay, it's created in, the plant world, or it's created in the dairy world, right? And we're just beginning to see a whole new branch of microbes that are cultivated from humans who are healthy and duplicated, made commercially viable. We kind of often consider these to be human native microbes. Can you describe the difference in what you see in the industry and what kind of probiotics you're seeing, and why a lot of times we get supplements that don't work? And then, if you were able to put a microscope to those microbes, you'd see they're already dead on arrival, or just can't last, getting to the colonization. And then also a third thing, which is prolification, like when we ingest a supplement, it goes to the colon, and then what should it be doing to be considered human native?
It's a lot of questions you've asked there, and it will be just these questions will take us 2 hours to answer them, but I'll try to be extremely short. So you mentioned two things, right? There is the first generation of probiotics that mostly either cultivated from dairy, as you've mentioned, usually isolated from cheese or cheese derivative, like the lactobacilli, the lactococcus, and the others. And there is the bifidobacteria that some of them also isolated from dairy, but some of them, they've been isolated from humans. Now we're getting to a new era of probiotic design. We call them the next generation probiotic, or the NGS, whatever probiotics they call them. And these are the ones that you've mentioned that are isolated from human, that we have seen that are increased in a healthy population and decreased in a diseased population. So when we take a healthy person and we compare it to a diseased, we see that the level of this bacteria is usually higher. We do mechanistic studies, let's say, in a case of Akkermansia muciniphila. It's a bacterium that has been identified as increased, although it's controversial, it's increased in a people that are healthy, they are lean, but it's a decreased in people that are obese, right? So we have isolated that Akkermansia muciniphila from healthy individuals. We cultivated into the lab, we increased its level, we looked into its safety and so on and so forth. We run clinical studies on it, usually in mice first and then in humans, and we show that actually consuming Akkermansia muciniphila, it increases certain metabolites like GLP-1 or the derivatives, and it contributes to some loss of weight in some context. Now, when you say why some people do take supplements, probiotics, and mainly, and do not work for them, is it because they are dead? In some cases, yes, I agree. Some, not very transparent and honest manufacturers do actually sell probiotics that are actually dead, and there is no way for you to check it unless you take them to the lab and try to cultivate them until you get them, you see them dead. Actually, if you want to do that at home, you can do that. You just take a potato, you cook it very mildly or so, you put some agar, you put it on a dish, you let it solidify, you take this probiotic pill, you open it up, you throw a little bit of it on the dish, you put it in, like in your oven, maybe at 30, 32 degrees. After a day, you will see if they grow, there is a bacteria. If they don't, there would be nothing. And that's how the first meat.
What a great science experiment. That's great.
Easy one. Easy one to do actually at home, right? I've done some of it with my daughter as well. So again,
fun.
like these are the media that we use in a lab. It's called potato starch. It's basically potato, right? It's just manufactured in a way that you actually can use it. But anyway, what I'm trying to say here is that in the event where the bacteria is actually live, right, and you consume it and it does nothing to you, it doesn't mean it's a bad probiotic. It means that the context in which that probiotic was taken is not beneficial to you. It could be because your microbiota is already populated with that bacteria, a lot of it, so you don't actually, it's like you're dropping just a small drop in an ocean. What would that do anyway? You already have that bacteria, so it wouldn't do anything. Number two, it could be outcompeted by other bacteria. Number three, it could have died during the passage through the gastric acid. That's why you would recommend that probiotic should be taken on an empty stomach in the morning, 30 minutes before you take your breakfast. Why? Because when you're sleeping, your acidity of the stomach decreases. You get more close to the 6.2, so that you give more chances on an empty stomach to actually get easily towards the colon. That's where you want that capsule to open up and get the bacteria to colonize. Right. So it doesn't mean that if a probiotic doesn't work, it doesn't mean that the actual bacteria is bad. It just probably also means that the condition in which was taken was not good, not optimal, not for the right people, not for the right person, not for the right condition, not for the right disease or the right health concern that you have. So all these needs to be considered to get into more of a personalization approach that, again, not all probiotic strains are the same, right? A strain meaning it's not just, let's say, Bifidobacterium adulensis is a probiotic species. Bifidobacterium adulensis AB01 is the strain that you need to take into account because strains are different and so on and so forth. And these are all considerations that one needs to take into account when you want to buy a probiotic. Problem is, for a layperson, this is not easy. As Justin Sonnenberg, professor or a doctor from the US, he said, for a person to understand if a probiotic is clinically relevant or not, they need a PhD, basically, right? Because again, it's so complex, and that's why us and others are trying to put some tools easy for people to understand and find the right probiotic strains, prebiotic strains for them to consume and get the benefit of that consumption.
Yeah, wow. And so let's go deeper with that on the idea of precision for each human, because what I'm hearing is, you can't just make this blanket statement that it's good for everyone. Context plays a lot into this space. So how does one gain context? Is it like, hey, I should be taking symptomatic surveys every couple of weeks? Is it, is there a database, that I should start creating? And then also, where does testing get involved here? What kind of testing? What are we looking for? Is it phenotype? Is it taxonomy? And then prebiotic fibers. How do we know what right prebiotic fibers are going to be right for us?
Excellent question. I'll start from the end, right? So a lot of people ask me what I should take if I am healthy. I said, you should take what you're healthy, start with your regular food, right? Increase your take of vegetables and fruits, because these guys actually contain a lot of fibers and some of them are already prebiotics. Again, not every fiber is a prebiotic, but most prebiotics are fibers, most of them, not all of them, right? So if you're healthy, just start by we call it take the rainbow. right? So it's a diversified type of diet, mostly looking like the Mediterranean diet, which has really showed its benefit and so on and so forth. But the problem we have here is that we are not living in a sterile, non-polluted environment, right? And people tend to forget that. How often do you go to the forest? How often do you walk bare feet? How often do you breathe pure air? How often do you not consume polluted water? How often do you drink water free of antibiotic? And then the list goes on. I could not stop here, right? How often your fruit and vegetables are not polluted with pesticides, you know? Although you may think you're actually consuming fruit and vegetables and that will be good enough for you, I do believe, and study shows that even if a healthy individual consumes fruit and vegetables, they do not get to keep their microbiota balanced. So meaning supplementing with the precision prebiotics or prebiotics that are designed to improve the composition of the bacteria to keep the gut microbiota healthy is, in my opinion, needed in many cases. Probably not in all the cases, but in many cases. That's when it looks into prebiotic. Now, how do you actually know which prebiotic you should be taking to populate the microbiota? In some cases, a prebiotic are enough. You don't need more than that. You just take prebiotics. Probably generic ones will do it. But in most cases, wouldn't, because again, we are all different. Your microbiota is your fingerprint. We are all different. We're not looking the same. Specifically, even within us, we're not looking the same at a younger age or an older age. That's where some testing will be interesting to see how you could basically identify which or which probiotic or which dietary intervention someone would be able to take in order to make the implementation needed. Now, when you speak about testing, it's a controversial, exciting, hyped subject, I would say, right? When you look into some of the doctors, GI doctors, specifically in Europe, they would say, oh no, GI microbiome tests, no, we wouldn't recommend that because it's yet to reach the clinic or yet to get clinical relevance. When you look into the States, we are much more advanced in terms of microbiome testing, and you have a lot of practitioners, even GI doctors, actually recommending microbiome tests and using the results. Again, it's always context dependent. So it depends on what's your question and what's your practitioner health provider is trying to answer. If you come with a specific issue, let's say SIBO or Crohn's disease or IBS or IBD or any other types of diseases, and you want to answer to that specific question, there are some tests that actually can address that and others who cannot, because again, they're not designed to identify the right microbial markers of the right functions to be able to even find the answer to those questions. They might find them in some cases, but they wouldn't know how to actually fix the problem they have found. So you would end up, it's like you're doing a blood test to find anemia, but your doctor doesn't even know that iron exists, right? So it would be a problem to recommend it. Now, in a general population or from a wellness perspective, that's what we see more these days, where probably they're not, they're willing to improve their health, or they're willing to at least keep it at the level they are. We speak more about the longevity element or the longevity aspect of what we're trying to do. Here, the benefits of testing will enable the actual individual to understand, number one, their state of microbiota, because that's something you wouldn't know unless you actually test for it. You can predict it in some instances, but test it is a different story. And then by knowing the composition of the microbiota, we could go into a personalization of the intervention that they would go, right? Personalization, whether that's with a prebiotic, so we identify what prebiotics we could give to keep that microbiota healthy or to improve its diversity. We spoke about that earlier. Or with a probiotic or with a combination of both. And this is what we see mostly advanced, let's say, in the States, coming to evolution or inception in Europe.
Wow. I always learn so much from you, Dr. Zorgani.
I
And
appreciate it.
you know, the gut microbiome world is fascinating in terms of, right, you said earlier, right, most people are, you know, I don't know if the word ignorant is the right word, but just, you know, it's not being talked about in a healthier, productive, beneficial way. But it seems like the world of medicine is shifting from just treating a disease, but to re-educating our bodies to be in a balanced state. You know, I was having a conversation with Dr. Andre Osterman from Stanford Prez, and he was explaining the concept of, we're not always trying to get to the best level. Sometimes just getting to neutral is the most important part.
Sure.
And so, you know, when we're talking about dysfunction, we're talking about chronic inflammation, symptomologies like allergies or gluten sensitivity or lactose sensitivity, or not being able to handle fiber rich vegetables. You know, hey, I eat some lentils and I'm bloated, and so are lentils bad for me, right? And so we would often think linearly and logically, okay, what can I do to stop the symptoms? And what I'm hearing from our discussion is there's a whole world that we're just not participating with. And the more we can slowly and simply learn, you know, maybe the first step for people is, I have a gut microbiome and it's important, right? Screaming that from the top of the mountain, rather than a lot of what we see, which is hacking the body and hacking the brain and trying to give it a bunch of stuff that maybe it does on its own. And we just need to allow it to do it on its own. And so I find that incredibly fascinating and incredibly exciting for humanity to start taking steps, you know. And so I guess one of the last questions I have for you is, as we look forward into the future, you know, and we see things that are really exciting, like CRISPR, you know, being able to change genes to edit them in and restore them without having to have a chemical process. You know, where do you see gut microbiome science taking us? You know, of course, you know, maybe you have a crystal ball next to you, but, you know, where do you see it being now, and how do you see it interacting? How do you see gut microbiome science interacting, right, with the wonderful things that are coming to humanity in terms of beneficial medicines?
I agree with you, and I definitely I would second all what you've mentioned about that. Right, it's like, you know, getting this knowledge of you know, getting to know that you actually have a microbiome is already a big step. A last survey from, I think, Biocodex Microbiota Institute is a large institution, how to say, not-for-profit institution. They've done a large survey around 7,500 people, and they asked them about the microbiome, and I think 3 out of 5 people state China and multiple countries. They do say they know about it, not very fully know what it does, but we're getting into more of awareness scheme. So that's a good news, I would say. Where could the microbiome science go in the next, let's say, 5-10 years? I think if the microbiome community or the microbiome research community embrace some of what we have seen, the uptake of AI, and what you have, you know, all the, like, I think the number of companies that are being created with the AI on the front of their name, it's, or on the end of their .com is mostly .ai now, or .io. It's insane. So that uptake is basically because there was an availability of an information and availability of tools that enabled companies to, or researchers, to build on the top of these large language models and to be able to use it in a multitude of different applications that goes from a very simplistic app that tells you you wake up at midnight or you wake up at 2 a.m. to probably robotics and how to land the rocket on Mars. In the microbiome field, we're not in the infancy, because, you know, we've actually known microbes way before we knew anything about the human biology, right? Like, that's the first thing we knew, even. but we still lack that foundational layer on which we could build upon. But that is getting solidified as we speak, and we are seeing more of that actually coming. And I do anticipate that in the next 10 years, I hope we'll be able to order microbes on demand or food of microbes on demand, that you would say, I want tomorrow to be, running a 10-mile race, and I want that my lactate level during the race will be at this threshold. And for that, I need this microbial composition and that food of microbes that I need to order. And the data will enable you through wearables, through connected devices, to actually use that data and be able to get the right dose of microbes for the right activity or for the right disease. Today, we come to see that there are some microbes that are involved in their natural microbes, and they have the natural ability to increase GLP-1 production endogenously. Like, you don't need anything else except of taking that microbes, and you have GLP-1 produced. You don't need Wegovy anymore. That's the only thing you need. And this is, I see the field evolving. Still some miles to go, but we're getting there slowly and surely.
Yeah, that's awesome. We are finding that, like something like Bifidobacterium adolescentis human native, has the ability to help people with lactose intolerance instead of having to, keep enzyme tabs with them.
Exactly.
And so you're rebuilding what was already yours, which is like a return to balance. And, often philosophically, these words can feel a little vague, but I think we're getting closer to making it less vague and more, specified, single strains that are really have a lot of benefit. And I think there's, there's a lot of room in the gut microbiome, diversity.
Absolutely.
If something like Prevotella is 50% of your gut microbiome and really it only needs to be 20, there's a lot of room for some other really great microbes.
Absolutely.
Yeah.
I will also add on that one, like, again, I applaud as well how the US is also moving towards that goal as well, right? Like, the new FDA commissioner, he's a big supporter of microbiome. In his book as well, A Blind Spot, he wrote this chapter about the microbiome, and he was amazed about how that field can actually change medicine, and I hope that will be incorporated into the FDA, how to say, strategy and so on and so forth. But I also see that there is a new wave of, national, incentive of wearables, right? My hope is there will be a national incentive of microbiome, that people actually know what their microbiome is and how to fix it and how to actually take care of it. And there are some, easy tips that people can actually incorporate in their daily routines. And there are other tips that actually need more research or more testing so that we can get to the bottom of actually wrong and how we can actually interfere, and probably add more tools to tweak it to get to the right results.
Yeah, it's an exciting time nonetheless.
Absolutely.
Well, thanks so much for your time today, Dr. Zorgani. It's always a pleasure to chat. As I've said already, I always learn so much from you. Wishing you well, and thank you again.
Thanks, Dad, and happy to be here as well.
Yeah, thank you. And to our listeners, it's clear that understanding and nurturing our inner microbial communities is a big key in unlocking a healthier gut microbiome and thus a healthier human. If you're interested in finding out what nutritional gaps your gut microbiome may be experiencing, you can go to elementlongevity.com, click the quiz tab, where we'll take you through a quick assessment. It only takes 3 minutes and can help you identify nutrient and microbe gaps that can positively support keeping your digestion and health more consistent and balanced. Thank you again for joining us on Upstream Science. My name is Darren Beckett. Bye for now.